Hey guys, welcome back to another edition of Geometry with Mr. A, your fearless host. All right, let me start out by saying this really quickly. You may notice I'm wearing the same shirt, so don't think that I'm wearing the same shirt 2 days in a row. I'm just actually recording this video on the same day as the last one. So, cool? All right, let's move on. Today we're going to talk about angle measure. Remember before we talked about segment measure here, now we're going to talk about angle measure. And so our objectives today, we're going to measure and classify angles, and we're going to identify and use congruent angles and the bisector. Remember that word, the bisector? This time it's an angle bisector of an angle. That was kind of redundant, wasn't it? All right, a ray. Let's start out with rays, okay? First of all, a ray has one endpoint and extends indefinitely in one direction. Here's what a ray looks like. Now you notice over here, there's no arrow on this side. This is the endpoint. A is the endpoint. And on this side there is an arrow, so that means it's going to continue on. Remember when we had a line, we had arrows going both directions. That's a line. We talked about a segment. We did not have this arrow. We only had just from point to point. That's a segment. This time we have an end point, and it goes on forever in the other direction. That is called a ray. All right, so here's how we name a ray. It says you state the endpoint first, and then any other point on the ray. So what's the endpoint? The endpoint is A, and it's going to go the other way. So we're going to start with A. When we call this, name it, we can use, one way we can do it is call it ray, and then we start with A because that's the endpoint. The only other point we know is B, so we would say ray AB. So we could call it ray AB. However, there is another way we could do this, just like it was with lines and line segments. There's a symbol for ray, so instead of writing out the word ray, we could still write AB. Notice it still has to be in that order. That order has to be in that order. With lines or segments, you could change it. With a ray, it has to be the endpoint first. And then you just make a little symbol on the top that is no arrow on the left and an arrow on the right. Notice it looks like this ray here. So those are the two different ways that we could name this ray. All right, opposite rays. All right, so opposite rays, the first thing is opposite rays will share a common endpoint. Okay, so two rays, they will have the same endpoint. If you see something that says things are opposite rays, you know this. You know that opposite rays are collinear. Remember that word collinear? That means they're on the same line. So opposite rays have to be on the same line. And therefore, the next point is they will form a line. So here's an example of two opposite rays that are forming a line. So if you look at this, hey, that looks like a line, just like we did before. It's made up of two rays. What are the rays that it's made up of? It's made up of ray PQ. Notice I said P first because PQ, that's this ray going this way. So that's this ray. Okay, sorry. That's that ray there. That's PQ. Now watch this. This is going to be really cool. I'm going to change my ink color. And so the other one is ray PR. So PR is starting there and going this way. So if you notice, ray PQ and ray PR, one goes this way, one goes that way, but they share the same point P and they make a straight line. That is called an opposite ray. All right, let's move on to angles. All right, now an angle is formed by two non-collinear rays with a common endpoint. So remember, opposite rays have a common endpoint and they made a straight line. Basically what's happening now is we've got an angle is made up of two rays that are not on a straight line. So this is what makes an angle, is that they're non-collinear. So remember, if these were collinear, they would be opposite rays. They would go straight across instead of making an angle like this. All right, so in an angle, the sides of this angle are the rays. And so like here, ED, so over here, and again, I would say E first, ED, that ray is this one right here. That's a side. And let's use that one. And then this one, EF, ray EF, and again, notice I said E first because that's the endpoint. That's the other side. Okay, so the sides are made up of the rays. Now, this is something that you may or may not have heard of before, vertex. Okay, vertex is the common endpoint. So basically, point E right here, that point right there, that's what's called the vertex. That's the point of the angle. That's the point where the two sides come together. That's called the vertex. All right, now when we name an angle, okay, there can be a number of different ways you can name an angle. One way that you can name it is if there are no other angles, like look at the middle, the vertex. Let's look at the vertex, which is point E. This is the only angle that can be made with E in the middle, right? So one way that we could say this is we could call it angle E. There's, of course, a symbol for angle, and it looks something like this. Hey, that looks like an angle, doesn't it? So we could call this angle E. In this case, we could do that because there are no other angles that are formed with E as their vertex. So that's okay in this case. Sometimes, however, there are multiple angles that can be made with E as its vertex, so we would have to call it something different. We could call it angle, and here's how it works. Sometimes this is tricky for people. You're going to use a point from one side, then the vertex, and then a point from the other side. Okay, so in this case, we could call this angle DEF. We could also call it angle FED. Notice what happens though, every time, the two ways I gave you here, E is always in the middle. Okay, so you always have to have the vertex in the middle. If you said DFE, that is not this angle. That's the angle that goes from D to F to E. It would be this angle over here. Okay, so that's how, oh, the other thing that sometimes can happen too is sometimes they'll put a little number in this angle. Maybe they'll put like a little 2 here. And if they do that, you could possibly call this like angle 2. That would be another way to do that if they label or number the angles. Okay, angles divide a plane into 3 parts. Okay, first of all, one part is on the angle. So right on the line, right on the ray on each side of this angle, that is considered on the angle. All right, what points that are listed here are on the angle? Well, G and P. So we have what? Points G, P, what else? E and R, right? So points G, P, and E and R are all on the angle. Okay, what else? There's the interior of an angle. All right, when you have this angle, basically the interior is going to be, it kind of makes sense, what seems like is inside of the angle. So it's basically in this, the smaller angle, I don't even know how to describe that, in the smaller portion that it makes up here. This will make more sense in a second when it's the well, let me just start this. Exterior is all this out here. So when you make this angle, the smaller portion in here, that's interior to the angle, and this larger portion out here is exterior to the angle. So if we want to name some points that are interior, what points would be interior? A, D, and F. So the points A, D, and F are interior, and what's exterior? Well, B and C would be exterior. Okay? All right. Let's do a few examples, kind of see how some of this stuff works. All right, name all the angles that have B as a vertex. Remember, the vertex is the point of the angle, okay? The part that makes the V, the vertex makes the V, okay? So B, here's B. right here, there's several angles that come off of this. B is right here, so it could be this angle right here, could be this angle, could be this angle, or it could be this angle. There are 4 different angles there. How do we label them? Okay, here's one thing that we cannot do. We cannot call any of these angle B, because since there are 4 of them, it would be confusing. Which one is angle B? Is it this one? Is it that one? Is it that one? Is it that one? We can't do angle B here. One way that we can do it, or if you remember, we can use the 3 letters. That happens probably most of the time. So if I'm going to do this one up here, I could call it G, B, A. I'm going from G to B and then to A. So I could call this GBA. I could also call it angle ABG. That would be the same thing. So that's this angle up here. These other angles, I could, notice they have a 5, a 6, and a 7. I could just call it angle 5, 6, and 7 if I wanted to. So I could say angle 5, angle 6, angle 7, and be done with it. Or, just to kind of show you what else, angle 5 you could also be called angle GBE. So you could also call it angle 5 GBE. You could also call angle 5 GBF if you wanted to. That's the same angle. So you could also call that angle GBF. That would also be angle 5. Angle 6, you could call angle 6 EBD. So you could call it EBD. What else could you call angle 6? What's that? Did you say FBD? Very good. So angle FBD. So if you did F, B, and D, then that would work. Also, the reverse that, DBF or DBE would also work. And then, of course, angle 7, the other thing that you could call that would be ABD or DBA. Okay? Getting a feel for that? All right, second example. Name all the sides of angle 5. Well, here's angle 5. It has 2 sides, right? Okay, which are rays. Okay, the 2 sides of angle 5 are rays. So the first side is this one right here. Are we going to call it GB? Ray GB? Nope, because G is not the endpoint. What's the endpoint? B. So we have to call this ray BG. That's this side over here. What could we call this side? We could call it, again, you have to start with B because that's the endpoint. We could call it BE, ray BE, or you could call it ray BF. Either way on that one. Okay? Example number 3. Write another name for angle 6. Well, we actually kind of did this. I actually did this in that previous example there because I gave you all the angle names. But if this is angle 6 right here, what's another name for angle 6? We could call it EBD. And like I said, we kind of did that before. I could also call it FBD. But I'm not going to, we already talked about that. Moving on, measuring an angle. Angles are measured in units called degrees. The degree results from dividing the distance around a circle into 360 parts. So if you think about a circle, I'm not sure how well I'm going to be able to draw this, but here's a circle. That is not bad. Okay, so let's say here's the middle of the circle, and let's say I'm going to start like from right here, if this thing will let me draw it long enough. So I'm going to start from right here, and if I start from here and I go around this circle and I split it up into like 360 parts, so it's like, 1, 2, 3, 4, 5, something like that, whatever. There's going to be a lot of them. There's going to be 360 of those all the way around. And so if I do, and this is probably not totally the scale here, but 1, 2, 3, 4, 5. I made 5. This is 5 here. So let's say I have an angle that went through here. So my angle was something like this. Okay, if this started at 0, how many of those 360 degrees around the circle did I have? 1, 2, 3, 4, 5. So in this case, this would be 5 degrees. And remember that little circle kind of up high there, that indicates degrees. Now in this case, this probably is not really 5 degrees. This is probably much more than 5 degrees, but that's as much as I can do right there. Does that make sense a little bit? All right. So we can classify angles depending on how many degrees they have. Okay, first thing is, you probably have seen this before. If you have 90 degrees, that looks like this, and that is a right angle. And you indicate a right angle with this little box in the corner. If you see that box in the corner, that means it's 90 degrees. Secondly, an acute angle is anything that's less than 90. So this dotted line here, that would be 90, and so the blue line is much less than 90, and so that is acute. And again, the dotted line is 90, and so that's bigger than 90, and so that would be considered an obtuse angle. All right, so what we're going to do here in example 4 is we're going to measure the following angles, classify them as acute, right, or obtuse. And we've got a handy-dandy protractor here. And so how you use a protractor, you may or may not have used this before, but it's set up for us to use. And so we set up our angle where one side is on the 0 line. So let's start out with CZD. Remember, CZD, C goes from C to Z to D. So that's this angle right here, okay? Do we all see that? So the C, the side with the C on it here is right at 0. What we're going to use is we're going to use these outer markings here, because this is 0, and you notice here's 10. Here's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20. So we're just going to go around the outside all the way around till we come over here. Here's 140, 150 is where the other side of our angle is. And so CZD would be 150 degrees. CZE, if you look at CZE, again, the C side starts at 0. CZE goes here. So we're going to go up to this line, and you go, oh, look at where that is. 90 degrees. That's a right angle. Now DZX, let's look at DZX is this angle over here. Well, it's not set up to be over here on the 0, but guess what? On a protractor, you can measure from both sides. So notice the side that has the X on it is on 0 on this side, but what you use is you use the inner readings. Notice what you have here, 10, 20, 30 going inside, going the opposite way. So this is 10, 20, 30. And so DZX would be 30 degrees. Okay, so that's a little bit about measuring angles. Oh, what we didn't do, we measured them, but remember we're supposed to call them acute, right, or obtuse. If it's 150 degrees, what's that called? Is it bigger than 90? Yep, it's obtuse. 90 is right, and 30 would be less than 90, and so that's acute. Good, thanks for reminding me. All right, congruent angles. All right, congruent angles, just like congruent segments we talked about before, congruent angles will have the same measure. And so how we can indicate that on a drawing, you remember when we indicated, like if we had two segments here, if I have this segment, and I called that A, B, and C, D, and if I wanted to indicate that those are congruent, and so I could put this little line through there, and that means that they're congruent, right? When we want to show congruent angles, let's say you have this angle here and another angle over here, like that. If you want to show that those two angles are congruent, and again, I'll change the color to make it really fun. What you do is, it says here, indicated by matching number of arcs. So what that means is I draw a little arc in here. That, in this case, it's blue instead of red, but that and that both have one arc in there, and so that means that those are congruent. You don't have to know what the degrees are, but you know that they're congruent. If you have multiple angles, one you might mark with one arc. If I made this 2 arcs and made this 2 arcs, that also indicates that these two are congruent to each other, but they would not be congruent to the angles that have 1 arc. Okay? All right, let's look at an example here. 5-pointed star is shown. Ooh, a lot of words here. Bleh. Okay, let's find GBH. GBH, so that's this angle right here. And HCI is this one. And it says GBH is congruent to HCI. So I'm going to mark GBH and HCI congruent. I put a little arc in there to show that those are congruent. And what else did it say? GBH is 2x plus 5 and HCI is 3x minus 10. If these are congruent, what do we know? These two parts have to be equal to each other. So I can write an equation. 2x plus 5 has to equal 3x minus 10. And we solve it using algebra. So remember our steps there. I'm going to do minus 2x to get this to cross out. Minus 2x. Then since this is minus 10, I'm going to go plus 10. 3x minus 2x is just x. And then 10, or 5 plus 10 is 15. And so x, well, see, I'm not going to, x is 15, but what did it ask us for? Find GBH and HCl. And so what we can do is they're both the same. So all I have to do is plug 15 either into here, this x, or into this x over here. Either way, it should give me the same number. So let's do 2x plus 5. So it's 2 times 15 plus 5. So that's going to be 30 plus 5, which is 35 degrees. So both of them should be the same. If you plug 15 in over here, it should give you the same exact number. Okay? Angle bisector. Just like before, remember we had talked about a segment bisector. It cuts the segment exactly in half at the midpoint. Well, in this case, an angle bisector is a ray or a line segment that divides an angle into two congruent angles. So like if you had an angle like this, an angle bisector would just split that right in two. And guess what? If it splits it right in two, that angle and that angle have to be the same. Okay? All right, so I believe this is our last thing here. Example number 6. Let's see what we can do with this. In the figure, CB, ray CB and ray CD are opposite rays. So CB, CD. So that means this is a straight line. Now, we didn't maybe necessarily mention this before when we talked about degrees, but if you have a straight line will be 180 degrees. Okay, so a straight line, that's line, is 180 degrees. So that's one thing we know about this is going to make 180 degrees, you know, all the way across there. What else? It says CE bisects. So here's CE. It bisects DCF. So that means it cuts DCF into two equal parts. So those two rays are equal, or those two angles are equal. CG, where's CG? Here's CG. It bisects FCB. And so I'm going to change color again here. I guess I didn't do it. And so that means these two angles. Now I didn't have to change color there because I have the two marks, but I just wanted to do it to make it a little more obvious. But those two angles are equal, but they're not equal to these ones over here necessarily. Now what do we know? DCE, so that's this one, DCE is 4x plus 15, and ECF is 6x minus 5. So this was 6x minus 5, and this was 4x plus 15. Those two are supposed to be equal, right? Because of the bisector here, CE was the bisector. So what do? We write an equation showing that those two are equal. And so we have 6x minus 5 equals 4x plus 15. And using algebra, we now solve it. So I'm going to do minus 4x. So these cancel. I'm going to do plus 5. So these cancel. 6x minus 4x is 2x. 15 plus 5 is 20. Divide by 2, x equals 10. Now, what were we being asked for? Let's see. Find, here's what it is, find DCE. We found x, which we had to find, but we're going to plug it in to find DCE. So DCE is 4x plus 15. And so the measure, oh, I just noticed something else that I didn't mention to you. See how this has the little m here in front of it? That's talking about the measure. All that means is the measure of angle DCE. If you just said angle DCE, you're talking specifically about the angle. If you say the m in front, that means the measurement or the degrees, basically. So the measure of DCE is 4 times x, which is 10, plus 15. So that would be 40 plus 15, or in other words, 55 degrees. So the measure of DCE would be 55 degrees. Okay? You're correct, or I'm correct. That was the last one. So, hey, appreciate you guys being here for another lesson. And take care. And I will see you next time for some more geometry. Bye.